Dear students, welcome to Digital Electronics lecture. Today is our first class and my name is Fahim. I will be your instructor for this course. In today's class, we will get into some important topics such as the number systems. We will see some examples on decimal to binary number conversion, binary to decimal number conversion, and so on. Before getting into the number conversion system, I would like to give you some examples, some secret tips that I believe these are not given in the book. In conventional book, you won't find this method of solving or converting a decimal number to binary number. I hope you all know about the decimal numbers. What is a decimal number? Decimal number has a base of 10. So say for example 105, if I ask you what kind of number is this, just by looking at it you will say that it's a decimal number, right? Somebody may also say that it is not a decimal number, it can be an octal number as well. Yes, it might be, but just by looking at a number, let's say if I just say we have a number such as 105, what kind of number will it be? 105, can you tell? Let's try to get into this. So as you can see, in the left hand corner we have the decimal numbers and the corresponding binary numbers are represented over here. So I have written down the decimal numbers 0 to 9 in this side and the binary numbers are written like this. Fine. So if I ask you, without looking at this table, if I ask you to convert a binary number, let's say we have 160. So if I ask you, or if I tell you that this 160 is given, what kind of number is this? This 160, can you tell? What kind of number is this? This 160, what kind of number is this? This is a decimal number, right? This number is a decimal number because it has a base of 10. So if I tell you to convert this decimal number into a binary number, will you be able to do that? I know you will be able to do that using your reference book, but before getting into that one, I will teach you a secret method. I won't say it's a secret method, I will teach you a shortcut method of solving this problem. So say for example, in the given question paper we are given with 160. 160 is our given decimal number. We have to convert the decimal number to a binary number. So the first step is to build a table like this. Okay, the first step is to build a table like this. How will you construct this table? Observe carefully. The first value that we will be having in the top right corner is 1. 1 getting multiplied with 2 gives us 2. 2 getting multiplied with 2 again gives us 4. 4 getting multiplied with 2 gives us 8. 8 getting multiplied with 2, 16. 16 multiplied with 2, 32. 32 getting multiplied with 2, 64. 64 getting multiplied with 2 again, 128. 128 getting multiplied with 2 again, we'll be having 256. So this is how you can construct a table. This is what you have to do. Fine. So once you have constructed a table, now get into the question paper. What number is given? The given number is 160, right? The given number is 160. So the first step is to find out which number is the closest in this table to this given 160. Let's try to figure it out. This 160, this number 160 is close to which number? Can you tell? This 160 is close to 128, right? Isn't it? Isn't it? So this 160 is closest to 128. And another thing you have to remember, that is the value that we are selecting from the table should be close to our given number, that is 160, as well as it should be less than the given number. So let's say here 256 is also somewhat nearer. It's also somewhat near to 160, but we are not selecting that one. Why is that? Because 256 is greater than 160. So in this scenario, we cannot take this 256. So we have to take 128. Fine. So once we have selected this one, we have to write a 1 underneath this one. Why? Because we have selected the closest value to the given value. Okay. Closest value to the given value, and put a 1 here. Once we have put a 1 there, what's the next task? What should we do next? The next task is to do the step number 1. That is, we have to subtract the value, this 128, from the given number, and it gives us a value of 32. Right? Then what we need to do? We need to figure out which number from the table is the closest number to 32. Right? Once we have subtracted, our duty is to find out from the table which number is closest. Now try to figure it out. 256, is it the closest number? No. 128, is it the closest number to 32? No. 64, is it closest and less than 32? No. What about 32 here? Is 32 less than or equal to 32 and closest to 32? It should be less than or equal. You need to remember this one, okay? Not greater than. So this 32 is equal to this given 32. So we have to select this place and put a 1 over here. Fine. Is it understood? So now what is the next step? We have to perform step number 2. So given this 32 comes here, minus this 32 is the 32 from the table itself, this 32, right? So 32 minus 32 gives us a value of 0. So we don't have to do anything further. So the next task, let's say it should be our step number 3, right? Now that we have performed step number 1 and step 2, it's our turn to do step number 3. Step number 3 is to fill up all the other vacant spaces with zeros. Here we have to put 0, 0. Here we have to put 0, 0, 0, and 0. So this is how we can get our final answer. So the final answer to this one should be 1, 0, 1, 0, 0, 0, 0, 0. So 1, 0, 1, then followed by 5 zeros. So this is what our final answer is. So in most of the books, this shortcut method is not given, but it is particularly handy for MCQ questions. So for solving MCQ questions, you usually don't get enough time to answer. So you can use this method and find out your answer within minutes. So this is how we can solve a decimal to binary conversion problem. So now if I ask you to find out, let's say 169. So let's say we have to figure out this 169. If I ask you to convert this decimal number to a binary number, will you be able to do that? So now your task is to find this thing out. Okay, so this is your homework. Try to do it at home, and the answer to this question will be given in the next video.